There we go. Okay. Hope everybody's doing all right. Good to see everybody today. Couple things. The big item, of course, is tomorrow. We are still planning on having our test. So I don't think a whole lot is going to change that. Even if there's a late start, fifth period, is not going to be affected. So unless just like nobody shows up, okay, we'll still plan on taking it tomorrow. You can still use your notes. And if they do end up canceling because of the weather, I think that's highly unlikely, though, because it really takes a lot for the school district to go ahead and cancel school for the day. We'll just go ahead and move it to Tuesday. But we'll kind of know in the morning. It's usually about 5 in the morning when the board members, I believe, start to get out and actually look at the roads and kind of check the conditions and decide what they're going to do. But they'll give text alerts. It'll be on the news, so just be paying attention to that to know what's going to happen tomorrow. But we are still going to move forward with the exam. The exam is just going to cover graphing the trig functions. In fact, the very first question is going to be just like the quiz last week, same type of setup, but it'll be a tangent, cotangent, secant, or cosecant graph. Yes, ma'am. Some of it, I want to say 3 or 4 questions are open-ended, like that graphing one. The rest of it's going to be multiple choice. Some of them will be match up the graph to this equation, find me the amplitude and the period, things of that nature. Hey.
You said we're gonna like it, so are we gonna be able to get to class on it?
Oh, no. I mean, I just think you're going to like the test in general. Because who doesn't like a test, right?
Oh yeah. I
Of
mean,
course. Yeah, especially it's math, right? Okay. Yes. Okay, so then, this material here, the inverses that we started, we're talking about today, is not on the exam. We're going to barely be able to really get into it before we take the exam tomorrow, so this will probably continue well into next week, just practicing and making sure that you guys feel comfortable with it. And I think, unless anybody has any questions, that's all I got. No. There you go. Well, if we're delayed, we'll still go ahead and take it. Yes. So tomorrow, if they do delay, we'll start at 10:15. That's what they sent out, and I went ahead. I did post that to the website if you were curious. But we'll go to first and second. We won't go to third and fourth, and then right after second, we would just go straight to either a lunch or fifth period, depending on your schedule.
like 2 questions.
Uh-huh.
Well,
Oh, yeah. So
whoa. Okay, so wait. Hey, what happens if we go to the ATC first and second?
if you go to the ATC first and second, I would just imagine, yeah, you'd probably just come here, and the cafeteria would most likely be the place where they would have all you guys wait until.
Also, tomorrow if like school does get canceled, like are we gonna have to make it up like during?
We will. More than likely, it'll be next semester. It won't be this semester. But if they do end up canceling because we do get that much snow or ice, whatever is supposed to happen, then yes, it'll probably be right around Easter, I think, is when they do that.
You think we're gonna have a white Christmas? I don't.
I don't know. I mean, it would be nice. I mean, my kids are that perfect age where I love to get outside with them in the snow. That a couple years ago when we had that massive snowstorm, that was a lot of fun. That was so much fun. And what really was not fun about it was my boss, or not my boss, my wife's boss, called and told her that she still had to go open her store, which was across town. So she gets in the car and she makes it maybe down the end of our block before she got stuck. So then I had to take the kids to the neighbors and they asked them, hey, could you watch my kids? Because I got to go dig my wife out of the snow. So I had to dig that out. And she still couldn't get any traction. And luckily, we got super lucky on this. It was right next to a bank. There were these guys going around and shoveling the sidewalks for this particular bank. I think it was Lubbock National Bank at the end of our street. And they had a chain on their truck. They hooked us up and they pulled us out of the snow. And well, what happened was while she was stuck, the boss called her and said, you know what, I changed my mind. There's just too much snow, so we're not going to open the store today. She works for Walgreens. Mm-hmm. Yeah. So I was like, wow, if only he'd made that decision just a little bit earlier, that would not have happened, yeah. But, I mean, it builds character, right?
I saw Dooley pick up.
Try to look on the bright side of things.
I saw Dooley pick up truck stuck in the snow.
Oh, wow. Oh, it's not good.
I'll tell you right now, if I gave my neighbor my kids, they'd probably take them. They'd sell them.
Wow, that that's a pretty shady neighbors right there. Just you go. I was only gone an hour. Well, they're already on the black market. I don't know what to tell you. All right.
Here's your hat.
Yeah. Yeah. I mean, if it makes you feel any better, here's the hat the kid was wearing. I mean, there you go. All right. So let's go ahead and get started. We were talking about inverse properties yesterday, and we really just kind of got to an introduction on this. We were looking at these right here, and let me kind of go big picture. When you're talking about an inverse, you take the x's and the y's and you do what? You switch them, yeah. The x values become the y values, and the y values become the x values. And when we're talking about these trig functions here, we evaluate a trig function at an angle, and our answer is always a ratio. You know, whatever ratio that may be. For sine, it's opposite over the hypotenuse. But if I'm provided the ratio and I want to know the angle that's created, well, we plug that into an inverse trig function. Now, whatever ratios you're able to plug in and whatever angle measures you're able to get out, trig functions have specific intervals that we have to look at for those. And that's where these come in. So right now, you know, we have no idea why these particular intervals exist, but let's go ahead, start getting into sine inverse and see if hopefully they become a little more clear. I think we already filled in the fill in the blank. Okay, we're good on that. Okay, well, let's get going. Now, all these steps are going to be the same for sine inverse, cosine inverse, and tangent inverse. We're going to start by graphing the original. Let's start by just graphing sine's parent. So sine start as a 0 or a maximum? It always starts at a 0. So let's say that this is pi. This would be 2 pi, so this is negative pi. All right, so we start at a 0. Then we go to a maximum. Then a 0, minimum, 0. And we can keep that pattern going. We'll just go ahead and fill the whole thing up. Okay. There we go. So there is sine's parent. Okay. So now my question is, do you remember yesterday we brought up an idea that we hadn't seen for a while? It was called one-to-one. And we determine if it's one-to-one by using a horizontal line. So I'm not 100% confident that my screen will work with me, so I'm going to use the mouse here. Okay. If I were to move a horizontal line into the graph, what would you say? Is it one-to-one or no? It is not. Okay, if it touches the horizontal line in 2 or more places at any time, well, it's not one-to-one. So this one is going to touch it in basically an infinite number of places because the graph is just going to continue. So this is not one-to-one. So this causes us a little bit of a problem because if we take the inverse, that means the inverse is not going to be a function. Those repeating y values would become repeating x values. So what we're going to have to do is scale this down. We're going to go ahead and cut some of the graph off so that he will pass the horizontal line test. All right. Now let's do that by finding the range. Okay, so let's find the range of this. How low does this graph go? What's the lowest value? -1, right? So here's -1. How high does it go? It goes all the way to +1. So it won't go higher than 1, and it won't go lower than -1. So that is my range, right? Now, what I'm wanting to do, as close to the x-axis as possible, I want to find x values. That's what it means when it says domain values. That will give me a range value. Remember, that's the y of -1 and 1. Okay. So remember, we're thinking about this in terms of a coordinate. I've got a point where the y value is -1. Well, as close to the origin as possible. What x value would correspond to -1 on the graph that we just made? Now, not 0, because if I were to go 0, 0 is 0, 0. Okay, it's at the origin, right? Okay, what kind of pi over 2? It would be negative. For the -1, it would be negative pi over 2, right? I'd have to go negative pi over 2 left, and then down -1. Okay. So that one is negative pi over 2. So what's closest to the origin that would give me a y value of +1? That would be positive pi over 2, yes. Okay. So here's what we're going to do. We're going to use these values to go ahead and restrict him. Because of this statement right here, we're going to say that his range needs to be between -1 and 1. Now, using these values, we're going to go ahead and list his domain. Let me get this horizontal line out of here. We're going to say that the domain can only exist between -π/2 and π/2. Okay. So anything that goes beyond a positive π/2, well, I'm just going to cut it loose. Anything to the left of -π/2, I'm going to cut him loose. Okay. So see, I only go from -π/2 to π/2. And the graph only goes from -1 to 1. So the graph wasn't originally 1 to 1. We cut off parts of him. We restricted him so that now he is. You'll notice if I go ahead and move the horizontal line through here, is he ever going to touch it in 2 or more places? No. So this is going to work out nicely. Okay. So let's think about this. Right here, I want to go ahead and graph the inverse, right? So this down here is going to be sine inverse of x. Well, remember, we just said when you're taking the inverse, what do you do with the x's and the y's? You switch them. So the domain of the original should become the what? The y's, the range of the inverse. So the range here should be the original's domain. So it should be -π/2 to π/2. Okay. So what should the domain of the inverse be? It should be the range, the y values of the original. See, the x's are becoming the y's, and the y's become the x's. That's exactly what we do with an inverse. So this is -1 to 1. Okay. Now, take a look at those intervals for just a second. -1 to 1, and then -π/2 to π/2. That's the domain and range of my inverse, right? Okay. Well, if we go back to the very first page, isn't that what we had there? Okay. So as we go along, you're going to start to see why we have those restrictions the way we do. Okay. I can only plug in a ratio for sine inverse if it's between -1 and 1. Remember, we kind of talked about that yesterday. Now, I can only get an answer from sine inverse if it's between -π/2 and π/2. Okay. Now, this might still be a little confusing, and that's okay. Once we get to an example, I think that's going to make it a little more clear. Okay. Let's go ahead and graph it, and then we'll finish filling in these blanks here. So you notice how I have -π/2 and π/2 horizontal? Those are the x's. Remember, now they're becoming the what? The y's. So now it's π/2 here, -π/2 here. In the original, 1 and -1 were vertical because they were y's, right? So now they're going to be what? Okay, so this would be -1, and this would be +1. Okay. And we can actually take these points and just go ahead and switch them out. Like this point 0, 0, well, it's still going to be 0, 0. But this point right here, he was π/2, 1. So what would that point be on the inverse? 1 and then π/2. This point over here, he would be -π/2, -1. Well, what would he be on the inverse? Oh. -1, -π/2. Okay, so he's going to curve up and then under, just like that. Okay, so that's the graph of sine inverse. Now, if I go ahead and compare it to this guy over here, and I didn't draw this little section as well as I could have, all right, if I go ahead and put this graph that I just drew on the same graph here, you'll notice it kind of makes that figure 8. Okay, that would be symmetrical with what line? What was it that we said yesterday you can reflect it over? Yeah, y = x. Okay, so it's like that line would just go straight through it. Okay, now the fill in the blank here, that's just writing as an inequality. compared to this. So this would be negative 1 and 1. This would be negative pi over 2 and pi over 2. Okay. So let's kind of bring all this together. Okay. Let's talk about what this means. Okay. The answers that you get from sine inverse is going to be an angle measure. An inverse trig function can only give you an angle, whether degrees or radians, and it depends on what mode your calculator is in. But it's very specific. Your answers can only be between negative pi over 2 and pi over 2. Okay. So if it can only be between those, that means we're restricted to the right side of the unit circle. We can only find sine inverse in quadrant 1 or quadrant 4. Okay. We're only going to be able to find sine inverse in quadrant 1 or quadrant 4. Okay, that's where we're going to go ahead and draw our triangles. And you might be asking yourself, well, what kind of triangles? Well, this is why we spent those couple of days talking about special right triangles. Okay, let's say we have two triangles. One is a 45 degree. The other is a 60, 90. Okay. Now, we were using n as our variable the past couple of days, but let's just use x. We know in a 45, 90, the two legs were exactly the same length. It's always x and x. But how was the hypotenuse written in terms of a leg? It was x square root of 2. Okay. And 30, 60, 90. The side directly opposite 30 was always x. How do I write the longer leg in terms of the shorter? Oh, not 2x. That's x square root of 3. And now the hypotenuse is always double the shorter side. Okay. Now, the reason we did that is because we need to recognize what type of triangles we have. If we create a triangle where we have these sides here, okay, let's say we have our reference angle, and we end up with a triangle that looks like this. Okay, why do you immediately say that's a 30, 60, 90? Yeah, there you go. Okay, that's exactly right. We need to be able to recognize what type of triangle it is. Now, here's the thing. How do you know it's not a 45, 45? These two legs would have to what? They would have to be exactly the same. And you can see the relationship here. Is 2 double 1? Yeah. And this leg over here, couldn't I take the shorter leg 1 and just multiply it by the square root of 3? Yeah. So see, that's what we're doing. That's why we need to be able to recognize the special right triangles. Okay. So let's get to some examples. Let's see what you think. All right, so we got 4 examples here. The first one says sine inverse of 1. Okay. Now, you don't have to write this out. I just want you to make the connection. Your answer is going to be theta. It's going to be an angle measure. An inverse trig function will always give you an angle. But you input a ratio into the inverse trig function. So if you were to write this normally, this would be sine of theta is equal to 1. If you wanted to write it the normal way, we're just working backwards here. Now here we don't actually have to do anything fancy. We can actually go ahead and use our graph. What's the value that I'm plugging in here? It's 1, right? So if you come back over to the graph, okay, well see, here's 1 right here. So what does that correspond to? Yeah, see, it corresponds on your graph to pi over 2. So I know that theta has to be pi over 2. Now, it won't always happen like that. Most of the time, you're going to have to create a triangle.
So like, say we get like sine equals x with pi over 2, we know that's gonna be like negative 1, like positive 1, because we know like, you know what I mean?
Oh, yes, but you can only plug a ratio into an inverse trig function.
Inverse, okay.
Yeah, so you won't be plugging a pi into an inverse. You can get an answer with pi out of it, but not into it. Okay? So let's try this other one and see what you think. This is more likely. B and C and D are more likely what you're going to come across. Okay. One's kind of like an exception. A is that. So it says sine inverse of -1/2. So I want to know the angle measure where sine is a -1/2, right? So if you were to write it normally, you could say sine of theta equals 1/2. Now, go back to what we just talked about. What two quadrants will sine inverse be restricted to? You can only find sine inverse in quadrants 1 and 4. Is everybody okay with that? Now, how am I going to know what quadrant to draw my triangle in? That's exactly it. You remember, what variable does sine represent? It was just y, right? So y is always positive in the first quadrant. It's always negative in the fourth quadrant. So depending on what you're given, that's how you decide where to put it. Because it's negative, I'm going to draw a terminal side right here. Okay? And I'm always going to connect it to my x-axis with a perpendicular segment. You're always going to create a right triangle doing that. So that reference angle theta is what I'm looking for. Okay? Well, how do we know what kind of triangle it is? What's sine's ratio? Sine is always what over what? It's always y over r. Okay. So the y value is 1. The radius is 2. Which one would have to have the negative? The 1. Okay. Your radius, your hypotenuse, will always be positive. Isn't that right, Jim? Okay. We'll always connect it to the x-axis. Okay. Well, you don't connect it here because we need the reference angle. The reference angle is the key element here. And that's always created between your terminal and the closest x-axis. Okay. Well, now, let's use the Pythagorean theorem to figure out what x is. Okay. What's the Pythagorean theorem? I keep forgetting. Okay, a squared plus b squared equals c squared. So here, x and -1 represent my a and b. So x squared plus -1 squared is equal to 2 squared. So what's a -1 squared? Okay, so that's just 1 equals 2 squared, 4. And now how would I go from here? Subtract 1. Okay, those are going to cancel. So x squared is equal to 3. And I need to take the square root to get x from x squared. So this is the square root of 3. Okay, that's exactly right. Once you create your triangle, you want to try to identify it as a 30, 60, 90 or a 45, 45, 90. Okay, now we can tell this is a 30, 60, 90. Is the hypotenuse double the shorter leg? Yeah, now don't worry about the fact that that's negative. The negative just tells me the direction that I have to go, right? And if I were to take the shorter leg and multiply it by the square root of 3, would I get square root of 3? Yes. Here's the only question. This one here, is that the 30 or is that the 60? How do we know that? Okay, across from 30 is always the shorter side. So this has to be 60. Now, my answer is 30, but I have to put a negative in front of it. Okay, now here's why. You always have to start rotating from the positive x-axis, from standard position. So if you rotate into the fourth quadrant, your value has to be negative. Okay, so that would give me -30. Now, what if I wanted it in radians? What's 30 degrees as radians? Times pi over 180, right? Okay, so you can get rid of the zeros. So that'd be 1, that'd be 6. So you could say, or -pi over 6. Okay. That's your process. You decide on the quadrant. You go ahead, draw your triangle, decide if it's a 30, 60, 90 or a 45, 45, 90. Okay. And actually, let me show you this. Sine inverse of -1/2. Here's how you plug it in the calculator. Go to calculator. Well, we know our trig functions are right over here by 7. So I'm going to click it. The bottom row are all of your inverse trig functions. So we're talking about sine inverse, right? What mode is my calculator in? Degrees. So is it going to give me the negative 30 or the negative pi over 6? Negative 30. Whatever mode your calculator is in, that's the answer it's going to give you. So if I were to type in sine inverse of a negative 1/2, it's exactly what we got. Now here's my suggestion. If you want radians, I wouldn't change the mode to radians because then you might forget. I would just take your degrees and like we did, multiply it by pi over 180. Okay. How are we doing? Does anybody have any questions on what we did here? Okay. Well, let's try another one. Let's try another one. We know this one was negative 30 degrees, or pi over 6, negative pi over 6. So now I want sine inverse of the square root of 2 over 2. Okay. So sine inverse. We're still looking for theta. If we were to look at this normally, this would be sine of theta is equal to the square root of 2 over 2. So first we have to decide what quadrant will this be in. Wait a minute, the last one was in the fourth. That's how you decide. Okay, where is y positive? Y is always positive in the first quadrant, negative in the fourth. So because we have a positive ratio, yeah. So that's what I'm going to do. And I'm just going to draw a terminal side. Doesn't matter how big you draw it. Okay. Now what do I do? Okay. So do I connect it to the y or the x? Always to the x. So this answer right here, that theta, that's what I want. Okay. So I got my triangle. I've got the quadrant. Okay. So sine is always y over r, right? So the opposite is the square root of 2. This one would be 2. Okay. And I would double check just to be on the safe side. How can I find x? What's that?
If the R is 1 right here, how is it 2 right here?
Oh, because that's your ratio. See, on this one, it was always y over r, and the same thing here. In this case, the bottom value is my radius. Did we have 1 on the previous one? On the previous problem, did we have a radius of 1? Yeah. No. In the previous problem, we had negative 1 right here and 2 here. Because negative 1 was your y value and 2 is your radius. That's what we had, yeah. Thought maybe I made a mistake for a second. It's very likely. All right. So let's go ahead and find x. Now, first off, is everybody okay with how I knew what quadrant? Okay. So we're good on that? So everybody's okay how I used the ratio and created my two sides. Well, remember, because we're always going to go from the reference angle, and that's created between the terminal and the x-axis, right? So whatever is directly across from it, that's your opposite. That's your y.
Oh, okay.
And then directly across from the 90, that's got to be your hypotenuse. Yeah, it's the same setup we've been doing for every right triangle. Okay. Use what? Oh, yeah, if you want to do that, you're fine. Oh, yeah. And if you want me to do the same thing, I'll gladly do that. Yeah. So we'll go ahead and say that's opposite over hypotenuse. I'm fine with that. Yeah. Okay. Mm-hmm. Okay. All right. Well, let's go ahead and do one more thing. Hey, thanks. Okay. Let's do the Pythagorean theorem. So if I have x square root of 2 and 2, what is the Pythagorean theorem for? So what represents a and b? There you go. So x squared plus the square root of 2 squared is equal to 2 squared. Okay. Well, what happens when you square a square root? Yeah. So this would just be x squared plus 2 equals 2 squared, 4. Now what? Subtract the 2. Okay. So x squared is equal to 2. And then we take the square root. So this length right here should be the square root of 2. Now here's my question. What type of triangle is it? How do we know that's a 45, 45, 90? Yeah. Two legs are exactly the same length. So I know that's 45. I know that's 45. So what's my answer? 45 degrees. Okay. Or in radians, pi over 4. Now wait a minute. The last answer was negative. Why is this one positive? Because it's in quadrant 1, and see, I would rotate counterclockwise. When you rotate into quadrant 4, if you're in quadrant 4, guaranteed your answer is negative. Okay. So I know this was a little unusual at the beginning. Does this make sense? Okay. And that's all we're doing with these. We're creating a triangle, and we're getting our answer. Okay. So we'll go ahead and continue doing this tomorrow. I'm going to go ahead and stop. We got about 7 minutes left. Okay. Because Jalen, I need to